Welcome to This Explainer. Today, we're tracing an absolutely wild, circular history of computing. We are going to journey all the way from massive, room-sized artillery calculators straight through to the consumer entertainment tools you probably use every single day. And then, we're going to watch as that very same technology loops all the way back around to power modern scientific breakthroughs in medicine. It's a brilliant, hidden narrative that's just been hiding in plain sight. So let's just dive right in. When you and I think of computers today, we usually picture those sleek little devices sitting right in our pockets. But this story actually begins with incredibly dangerous, room-sized machines that needed massive amounts of high voltage just to turn on. And it finishes with a technological loop that's literally unlocking the structure of life itself. You know, the hype cycle around all this started incredibly early. Way before you had a smartphone, press predictions back in 1948 were already hyping up these so-called electronic brains. Take Lord Mountbatten, for example. He predicted that these machines would simultaneously revolutionize high-end scientific calculations and, somehow, instantly cook a family dinner. I mean, even back then, the expectations for technology were just running wildly ahead of reality. But the actual foundations, they were laid incredibly rapidly. In the 1940s, we got the Adenosoft-Berry computer, the ENIAC, and the Manchester baby. And let's be clear, these were not consumer devices. They were highly dangerous valve-powered machines. Some of them literally looked like a giant bag of bolts, and you could get a lethal electric shock if you just stuck your hand in the wrong place. They were custom-built by government and corporate labs strictly to solve insanely complex scientific equations, like plotting artillery trajectories. Now, there's a persistent myth you might have heard that IBM's founder, Thomas J. Watson, once famously declared the world only needed 5 computers. Well, that's actually not true. He recognized a massive demand right from the start. What he actually said was that there was a huge market for specialized, highly expensive scientific machines that were renting for up to $18,000 a month. He totally knew they were valuable. He just saw them purely as tools for the science lab. Moving on to our next era. Mainframes enter the office. The transition out of the lab changed absolutely everything, mostly because businesses quickly realized the sheer power of data processing. Picture this. It's the 1952 U.S. presidential election. CBS television decides to bring in the UNIVAC computer to predict the results. With only 5% of the vote counted, UNIVAC predicts an absolute landslide for Eisenhower. It was a feat of numerical analysis so completely shocking and so contrary to the human polls at the time that the CBS anchors totally panicked. They actually refused to broadcast the prediction at first. But the crazy thing, UNIVAC was entirely accurate. Meanwhile, over in the UK, a British tea shop company called Lyons, which was essentially the Costa Coffee of its day, built LEO. And LEO wasn't just the first business computer. It was a total revolution. They didn't just use it to manage their tea shops. They effectively invented off-site cloud computing in the 1950s by acting as a computing bureau. They were literally running the payroll for giant outside companies like Ford UK. Which brings us to the personal software revolution. Moving these computers from a freezing corporate basement onto our personal desks in the 1980s was a massive leap. But early word processors? They were really just incredibly expensive, glorified typewriters. In 1976, the IBM Mag Card 2 cost $11,000. By 1981, companies were desperately trying to sell dedicated word processing machines to the public. There's this hilarious television advert for the Lanier Easy 1, where a character excitedly asks if the machine will literally clean Windows. Keep in mind, this was years before Microsoft Windows even existed. People were just trying to wrap their heads around what these desktop machines were actually supposed to do. Ultimately, software became the real battleground. Microsoft Word eventually crushed superior competitors like WordPerfect, using aggressive bundling and a really clever strategy called format lock-in. Basically, once you used Word, its unique file format trapped you. You couldn't easily export your work to any other program. It was a super aggressive but highly effective commercial choice that completely shaped the modern office we know today. This era also gave us the birth of the killer app. If you haven't heard the term, a killer app is a program so incredibly desirable that you'll go out and buy a whole new computer just to use it. The very first true example of this was VisiCalc. It was an early electronic spreadsheet, and it was so revolutionary with its what you see is what you get grid that consumers bought thousands of Apple II computers specifically to run it. Now, if you think using a spreadsheet is revolutionary, imagine trying to give a high-end business presentation before 1987. Before Microsoft acquired PowerPoint, giving a lecture was a literal nightmare. There's a famous lecture called the Photon Connection that required a bank of 18 separate 35mm slide projectors that were constantly jamming, along with 2,000 manually controlled cues. PowerPoint came along and took that entire noisy, chaotic physical process and magically turned it into a single, seamless digital file. All right, next up, media, graphics, and games. We are now at a critical pivot point in the story. How computers evolved from just processing boring office text to handling dynamic media and interactive games. And here is a massive historical surprise for you. The telecommunications industry actually held patents for digital transmission technology way back in 1921, literally a full century ago. So why on earth did it take until the 2000s for us to finally get digital music, streaming video, and services like Netflix? Well, the massive delay really boiled down to overcoming three major technical hurdles. First, generating enough sheer bandwidth. Second, physically getting the internet into people's homes at a massive global scale. But the third step was the real magic: extreme data compression. Innovators had to figure out how to compress data so heavily that it was like fitting the massive River Thames into a tiny little stream, but doing it so perfectly that our human eyes and ears couldn't even notice the difference. Right around this same time, computing was also becoming interactive. Back in 1962, hackers at institutions got their hands on the PDP-1. Unlike the old punch card machines, this was a machine you could actually sit down and interact with in real time. They ended up creating an early graphical game called Space War, which they played on this primitive, glowing screen. This simple act of shooting tiny digital spaceships at each other sparked a desperate, relentless consumer demand for better, faster, and much more detailed interactive graphics. And you know what? That explosive demand for visual computing was heavily driven by one incredible academic hub, the Computer Science Department at the University of Utah. The alumni from this single university went on to found absolute titans of the modern digital world. We're talking Pixar, Netscape, Adobe, Silicon Graphics. They effectively pioneered the real-time visual processing that completely defines our modern era. And that brings us to our final section, the innovation cycle completes. This is the grand finale, where consumer entertainment hardware loops all the way back around to its scientific roots. Because gamers constantly wanted better graphics, the hardware evolved at a breakneck pace. We went from basic 2D pixel processors like the S3911, which was humorously named just because the inventors really liked Porsche cars, straight into incredibly powerful real-time 3D rendering engines. These high-end chips were purpose-built to process millions of 3D shapes in literal milliseconds. But here is the absolute best twist in this entire journey. If you look at how hardware giants like NVIDIA market their most powerful graphics cards today, they aren't just pitching to gamers anymore. Their website literally says, the Titan RTX powers AI, machine learning, and creative workflows. The exact same specialized graphics cards that were invented purely to make our video games look pretty are now the essential, bleeding-edge tools for complex scientific problem solving. To really understand why this matters, just look at what these gaming processors are being used for right now. During the pandemic, scientists in Norfolk, England, used this exact computing power to sequence over 10,000 COVID genomes. Modern genetics is essentially a massive string matching problem. By utilizing the incredible parallel processing power of GPUs, scientists can now rapidly match genetic strings and track the global and local lineages of diseases in real time. It's just incredible. And it goes even deeper than that. These same processors are now powering mind-blowing AI programs like DeepMind's AlphaFold 2. Predicting exactly how a protein folds itself up into a complex 3D structure is legitimately one of the hardest problems in all of biology. But by feeding this data into supercomputers powered by technology born straight from video games, AI is successfully learning to predict these structures. We're effectively unlocking the fundamental building blocks of life. So, we've watched the history of computing come completely full circle today. We started out with massive, dangerous machines designed strictly for scientific calculation. Then we moved into the business world, built personal consumer tools, and relentlessly chased better entertainment and video games. And now, the technology created for our living rooms has looped right back around to become the ultimate engine for scientific breakthrough. It absolutely proves that today's consumer toy is tomorrow's scientific instrument, which leaves us with one incredibly provocative question to take away. As this continuous wheel keeps spinning, what exactly will the next loop invent?